Have you ever just stopped and wondered what the universe was like at the very, very beginning? I mean, before any stars, before galaxies, before literally anything we'd recognize today? Well, that's what we're doing today. We are peering back into the cosmic dark ages to find the story of how the first ever structures in the universe got built. So let's go. Time to wind back the cosmic clock.
It's a pretty simple question, right? But the answer, well, the answer is just incredible. To even start to figure it out, we have to go way back to a time when the entire cosmos was basically a blank slate, filled with nothing but the simplest ingredients you can imagine.
We're talking about a universe that's only a few 100,000 years old. I mean, that's nothing compared to the billions of years it's been around. And back then, the only things that existed were the two lightest elements, hydrogen and helium. That's it. A really simple but a very, very hot beginning.
Just try to picture it. The whole universe is this glowing, white-hot fog of individual atoms. At 3,000 Kelvin, it is way too hot for anything to actually stick together. Everything is just zipping around in this, chaotic, uniform soup. But the universe does what it does best. It keeps expanding and cooling. And that changes everything.
And right here, this is where we see chemistry make its very first, really hesitant appearance. As the universe cools down to about 1150 Kelvin, a few stray protons kind of nudge a couple of hydrogen atoms to stick together. Then, as it cools all the way down to basically room temperature, which takes millions of years, by the way, free electrons help a few more join the party.
So, after all that time, after all that cooling, what did we manage to build? A grand total of 19 molecules. Yeah, just 19. It's an almost unbelievably slow, difficult start. This was the universe's very first tiny little act of construction.
So the universe keeps on expanding, keeps on cooling, and you think, okay, that's the whole story. A huge, almost totally empty space with just a handful of molecules floating around. But here's the twist. That picture is completely, and I mean dramatically, wrong. There is a gigantic piece of the puzzle missing.
And this brings us to a massive cosmic mystery. It turns out all that hydrogen and helium we were just talking about, all the stuff that makes up stars, planets, you and me, it's only a tiny, tiny fraction of what's actually out there.
So, okay, let's take a little inventory. Imagine we could somehow put all the normal matter in the universe on one side of a giant cosmic scale. What would we need to put on the other side to make it balance? The answer is, well, it's staggering. And wow, this really puts it into perspective. For every 100 grams of the stuff we know, the atoms, the elements, there are 530 grams of something else, something invisible, something we can't touch, and something completely mysterious that outweighs everything we can see by more than 5 to 1. This right here is one of the biggest questions in all of science. And our source material for this explainer proposes a pretty radical, kind of mind-bending answer for what this invisible majority is really made of. Okay, so to get our heads around this radical new idea, we have to start with one of the most famous and mysterious objects in the entire cosmos, the black hole. Right, so we usually think of black holes as these giant, kind of terrifying monsters that form when huge stars collapse. They're these regions of space so incredibly dense that their gravity traps everything, even light itself. But what if? What if there's something way more fundamental? So here it is, the core idea. This invisible matter isn't some exotic, undiscovered particle we're hunting for. Instead, it's made of countless microscopic black holes that were forged in the very first moments of the universe. Now, this isn't just a wild guess. The source actually argues it's a natural result of our deepest understanding of physics. So, how do we get there? Well, the key thing is that this idea brings together the three pillars of modern science. The source argues that when you combine the universal pull of gravity, the cosmic speed limit from relativity, and the just plain weird fact from quantum mechanics that everything is both a particle and a wave, well, the math suggests that the most fundamental particles should behave exactly like microscopic black holes. They're not some exception to the rules, they are the rules. This quote really gets to the heart of it. The argument is that every single particle, an electron, a photon, you name it, is fundamentally a tiny, spinning black hole. I mean, think about that. This totally reframes black holes not as destroyers of matter, but as the fundamental building blocks of matter itself. Now, if that's true, it completely changes our picture of the early universe. It means that long before those first 19 molecules ever formed, a huge, invisible architecture was already starting to take shape in the darkness. So, from the moment of the Big Bang, these countless microscopic black holes would have started pulling on each other, colliding, merging, and over hundreds of thousands of years, they would have woven themselves into this enormous universe-spanning network. And this structure has a name: the cosmic web. The best way to think of it is like a hidden skeleton for the universe. It was there from the very beginning, an invisible blueprint that would dictate where everything else was eventually going to go. And it played an absolutely crucial role at a key moment in cosmic history. See, early on, the universe was so blindingly bright that the sheer pressure from all that light was literally pushing normal matter apart, stopping it from clumping together under gravity. But once the universe cooled down enough for that light to finally travel freely, that pressure just vanished, and suddenly gravity was completely unopposed. And what was waiting for all that normal matter to fall into? And this analogy just hits the nail on the head. That invisible cosmic web of black holes acted just like scaffolding for a building. The moment that light pressure was gone, all the regular gas, the hydrogen and helium, it just started to fall onto this pre-existing structure, tracing its pattern and beginning the process of building the first massive structures in the universe. So, as all this normal matter begins to settle onto this hidden framework, the universe enters the final phase of its long, dark childhood. The stage is being set for the next great act. But here's the thing. This massive construction project is happening in total darkness. The universe is still expanding, it's still cooling, and the last little remnants of light from the Big Bang are fading away. The brilliant white-hot glow of the early cosmos cooled to a pale yellow, then a vivid orange, and finally a deep cherry red. And eventually, even that faded, leaving only a faint infrared warmth and a universe of uniform, absolute darkness. So there it is. In this cold, dark void, an invisible scaffold was now draped with all the raw materials of creation. The cosmic foundation was complete. And the question that was left hanging in the darkness was, what would be the first thing to ignite that darkness and build upon that incredible, grand design?